So sometimes we can look at a graph and get symmetry from the graph if it's just a y equals, which this one is, but sometimes I might give you one that's not one we could just put in our calculator. So we'll talk about this and then I might throw another one up here. How do you check symmetry to the x-axis?
Change the y.
Right. What that means, if it's symmetric to the x, then a positive x and a negative x give you the exact, whoops, that's symmetric to the y. Positive x and a gives you two different answers, the positive and the negative y. Okay, so it looks something like this. So we replace the y with a negative. Is there any way to turn that back into the original?
No.
So it's a no. If you didn't have this or you messed up, feel free to write this down. That's why we're going through it. So if we check the y-axis, if it's symmetric to the y-axis, then a positive x and a negative x should give you the exact same y value. So when you do this, make sure you are replacing your x with a negative. If you square a negative, what happens?
Positive.
So is that what we started with?
Yes.
So that's a yes. How do you check the origin?
Do them both.
So if I make my y negative and my x negative, this one disappears, but the other one doesn't, so it's a no.
So if we were to look at the first two, I feel like I asked this before. Yeah, it's no, yes. The origin would automatically be no.
Right.
Okay.
What if I gave you something like,
Yes.
Is that a y squared or a 4?
Y squared.
so yeah, if you check the x-axis on this one, if you make your y negative, a negative squared becomes positive. So that's a yes. If you check the y-axis and make your x negative, then that one's also going to be a yes. How do we check the origin?
Both.
Yeah. So I just wanted to throw this one up just to remind you, you don't have to have just one yes. It could be multiple yeses, so you do have to check them all. If it's one that we could look at on a calculator, like this one, could we have graphed it?
Yes.
Yeah, if I gave you one like that and you're using the graph to answer it, then please show me something. So at least maybe draw a sketch of the graph so I know you didn't just randomly guess yes or no. That justify your answer. How did you get it? If you graph that one on the study guide, it's like a parabola shifted like this. So we could see if you fold that over the y-axis, it overlaps itself, and not for the other two. So there's an algebraic way of doing it, and then there is the graphing way of doing it. Any questions about that?
No.
Number 5. Greatest integer. So when we look at a greatest integer graph, we know it's going to look like what? Okay. So we always made a t-chart. If we started by just plugging in a 0. 1/3 times 0 is 0. Greatest integer of 0 is 0. Minus 1 is -1. If you put in 0.5, 1/3 times 0.5, that's 1/6. What's the greatest integer of 1/6? 0 minus 1 is -1. If I put in 1, 1/3 times 1 is 1/3. Greatest integer of 1/3 is 0 minus 1 Okay, so when I put in 1, I'm still getting out -1. So have I jumped steps yet? No. What happens if you put in a 2? You get 2/3. Greatest integer is still 0 minus 1 is -1. Alright, when you put in a 3, 1/3 times 3 is 1. Greatest integer of 1 is 1 minus 1 is 0. So 3 is when we jump up here. So the steps are 3 units long. And then you jump up. What was my rule when you graph these? What did I ask you to do?
3 levels.
A minimum of 3 steps. And then what did we put to show it keeps going?
Dot, dot.
Because that pattern just continues. Is that okay? Number 7. Okay, so when I look at these, I would expect a parent function and the final transformation. Parent function has to have a minimum of 3 exact points. What is my parent function?
Of x equals the square root of x.
Square root of x. Okay. So you'll get a point just for drawing in that parent function. Square root of 0 is
0.
square root of 1,
1.
square root of 4.
2.
Can you put in negatives? No, so the parent function looks like this. Okay, if you write out those pairs, you're welcome to do that too if it helps you. So what are my transformations here? What's the -2 going to do?
Right,
And the 3?
vertical shift.
Okay. So outside, does that change x or y?
Y.
Outside is y, and it does what it says. So when it says the 3 on the outside, we are just taking our y values times 3. So if you think about these, 0 times 3 is still 0. 1 times 3 is 3. 2 times 3 is 6. And then I also have to move them to the right. So if I took 0, 0, and then move it right 2. This would be at 1, 3, and then right 2. This would be at 4, 6, and then right 2. And so we see our graph is getting really tall, like that. What's the domain and range of that?
2 to infinity for the
Domain, bracket 2 to infinity. Range would be bracket 0 to infinity. If you struggle with the stretching and shrinking, what are ways you could check yourself?
plug it in.
Could you look at a graph on your calculator? It's not necessarily giving you the exact points you need, but it would show you if the shape of yours is correct. If you really got stuck, could you make a T-chart for this? Yeah, so if you get confused on the stretching and shrinking, don't give up. You have a couple tools that could help you get to that answer. All right. Is that okay? Next one was number 14. Okay, so the domain of g divided by f. So function g is 4x plus 4. Function f was 3x squared minus 2. When we're talking about domain, that's the possible x values. When I have a fraction, what cannot happen?
0 and the
the denominator cannot be 0. So 3x squared minus 2 can't be 0. So add over your 2 divided by 3. How do you get rid of a square?
Square root,
When you add a square root, you need.
plus minus.
Okay, so this is the same thing as saying the square root of 2 divided by the square root of 3. Can you leave a radical on the bottom? No. So you might have had the square root of 2/3 and that didn't match my answer. That's because I got the radical off the bottom. So it cannot be the square root of 6 over 3, plus or minus that. My general rule, if it's just one thing that x can't be, then you are allowed to, or then you're expected to put it in interval notation. If it's more than one thing that x cannot be, then you're allowed to say x cannot equal and list them. Is that all right? Okay. Number 16. All right, if I have this on the test, it would actually be a 3-part question. So I'd say part A, give me f of x plus h. Part B, give me f of x plus h minus f of x. And part C is the whole thing. All right, so on that, f of x plus h, what does that mean?
Put x plus h in for x.
You go to function f, and you replace the x with an x plus h. All right, so x plus h squared. That means there are 2 of them, so we have 2 FOILs. So x times x is x squared, plus xh and plus xh would be 2xh. H times h is h squared. Distribute the 3. And we get that. Is that okay? Mm-hmm. Then in part B, I would say, okay, now give me f of x plus h minus f of x. So f of x plus h is what we just worked out. So we'll carry that answer down. Minus f of x is the original function, which was 3x squared minus 2. The biggest problem I've seen on these is not putting parentheses here. Why is it so important that I have those parentheses?
So you distribute the negative.
Mm-hmm. So if I take that negative through, positive 3x squared and negative 3x squared cancel. Negative 2 and positive 2 cancel. So we get 6xh plus 3h squared. And then I would say part C, f of x plus h minus f of x, that's what we just worked out. So I want that divided by h. So if we cancel an h out of everything, we get 6x plus 3h. So on the study guide, I know I didn't say ABC, I just kind of threw it all together. But on the test, I would break it down into pieces for you. Is that okay? Seventeen C. G composes composed with f of 1.5. So when we have a composition, what are we supposed to do? Plug one thing into another. Okay, another way this might be written is g of f of 1.5. So f of 1.5, function f was -2 over x minus 5, so if we plug in a 1.5, and we're not getting a beautiful answer there, what does that give us?
2 divided by 3.5.
Okay, which is?
0.57142857.
Change it to a fraction for me.
2 over 3.5.
That's what I said.
No, that's 2 over 3.5 and then hit math number 1, what's that as a fraction?
4 over 7.
4 over
Oh
7.
my god, I'm getting 3
I just didn't want a fraction in a, or a decimal in a fraction. Okay, so now g of 4/7. If I go to function g and plug in a 4/7, so we have the square root of 4 over 7 plus 6. This one was kind of ugly, so I did tell you that if you gave me a decimal, that was okay. So if you type this all in your calculator, you get 2.5635, that's fine. If you didn't, if you kept the fraction and just simplified, so you get the square root of 46 over 7, you could get the radical off the bottom. So that gives you a pretty nasty looking thing here, but I would accept either of these because this was just not a very pretty composition.
Could we have kept it as the 4/7 plus 6?
No, I would want you to simplify that. I mean, it would be like a half point off for just not simplifying it.
So are you continuing to multiply the radical on the bottom in the denominator? Why does that not cancel out the radical? Oh, never mind, it's because it's not. Yeah, yep, okay.
Okay.
Yep,
Good?
yep. It's not a square root.
It
It's
is.
not a square. Got it. Yep.
All right, we did not ask about 19, but I want to go over 19 because we had this one on the quiz, or one very similar, and there were a lot of mistakes on that. So f of x is 3 over x. G of x is 5 over x minus 1. So g composed with f, that means g of f of x. So f of x is 3 over x. I am plugging that into g. So I get 5 over 3 over x minus 1. What's wrong with that?
A fraction and a fraction.
Right. We do not like to leave a fraction in a fraction. So we could multiply top and bottom by x. So that gives me 5x over. On the bottom, I'm distributing. 3 divided by x times x is 3. Minus 1 times x is x. So that is my composition. The domain. This is the one where you have to look a couple different places for the domain. Where do we have to look at?
The original.
The original thing you plugged in, the inside function, and the final answer. So when I look at my inside function, what can x not be?
0.
0.
When I look at my final answer, what can x not be?
3.
And that's because in a fraction, the bottom can't be 0. So for my final domain, since I have multiple values, you are allowed to just tell me that x can't be a 0 or a 3.
Can you look at this and tell me if this is how you would write it though?
That is
How did you know the x?
I like it.
Today's the day.
Today's it. it's a good day. It's a Monday. All right, number 22. So I want to know if this function is even, odd, or neither. This is very closely related to symmetry, which means there's a couple different ways of doing it. You have to justify your answer to me somehow. So I don't just want you to write the word even or odd. What are your different options for figuring it out?
Algebraically.
Algebraically says you plug in a negative for the x. So I would have a negative x to the 5th minus a 2 times a negative x cubed. If you take a negative to the 5th power, is it positive or negative?
Negative.
A negative cubed. Negative, and a negative times negative makes positive. So, even means it's exactly what you started with, and it is not. Odd means it's the exact opposite, which this one is. So that would be odd. So that's one way of doing it.
This is the one where you only have to check one.
Yeah.
Figure it out.
What's another option? Graph it. If you graph this, so x to the 5th minus 2x cubed. So even is the same thing as symmetric to the y-axis. Odd is the same thing as symmetric to the origin. If you graph it, it looks like this. So is that symmetric to the y-axis? No, if I fold it over the y, it doesn't overlap itself. If I fold over the y and the x, does it overlap?
Yes.
Yes, so this is odd. So either do the algebraic way, or if you're looking at a graph, draw the graph and justify it that way. Okay, just somehow let me know why you picked the answer you picked. All right. What else? Maybe you got it right, but that was Friday, so what else do we need to review? So we know functions and transformations, domains and ranges from those. You guys can handle all of that. We've talked about the symmetry. What does it mean to be increasing?
When the graph is going up,
Yeah, as you're going from left to right, it is rising, decreasing,
he's going down.
and constant is, of course, horizontal line. Should we review graphing a piecewise, maybe?
No.
I thought it was pretty easy.
Okay. What does it mean to be continuous?
When you don't have to pick up your frequency.
Yeah, so if I ask you to give me the intervals where it's continuous, you're looking at where can I draw it without picking up my pencil. Give me the x values when you're telling me that. The only time you use y is for the range.
If you're continuous, couldn't you just put your increasing and decreasing?
Well, I mean, you might have breaks, but yes, it should be essentially the same pieces.
Okay.
When you list increasing and decreasing, do you give the x or the y values?
X.
The x values. You're listing an interval with the x values. How do you know if something's a function?
Vertical line.
Passes the vertical line test. What else? Let's see. You guys are good with domains. If it's a fraction, what do we know?
Can't be a 0.
The bottom can't be 0. If it's a square root,
Greater than or equal to 0.
greater than or equal to 0. All right, let's review. I'm just going to make up a couple problems.
Can I use the restroom right quick?
No.
Got you.
Silly.
All right.
I wanted to be really silly guy like that too.
Two problems.
Oh.
I mean,
All right.
still 2 problems.
How do you solve a problem like this?
Set the right hand side rules.
Okay. It's an equation, so you make 2 problems. The first one, nothing changes. The second one,
Take the opposite.
you have to run a negative through one side. Okay, so then we solve these. X to be 5 for the first one. And 1/11 for the second one. On the equations, you're allowed to just tell me X equals those things. You're not writing an interval because it's not everything in between them, it's just those two answers. So that's an absolute value equation.
Would it matter on those equations if there was something outside of the absolute value?
It could, you just want to check your answer and make sure it will work. Let's talk about when we did the inequalities. So if I said this, what do I have to do?
2 equations.
2 equations. Is this an and or an or? Or. So that means I would expect my answer to be like negative infinity to something, union something to infinity, right? Those are what we get for the ors. So we do the first one. Or how do you do the second one?
Flip the sign in the opposite. Negative.
So you get 3x is greater than or equal to 9, so x is greater than or equal to 3. And this one, x is less than or equal to 1/3. So it would be negative infinity to 1/3, parenthesis or bracket, union, bracket, 3 to infinity. So greater than, or we should get 2 separate intervals. The third scenario.
And.
Okay, always make sure you isolate your absolute value first. Then less than is
One.
and. We should just get one interval between something and something. You can still write 2 if you prefer. A few of you do that. Most of you set it up with one big compound inequality. So if you subtract your 8 from everything, divide by 5. So we're going to get everything from negative 18/5 to positive 2/5. Parentheses or brackets?
Parentheses.
Parentheses because it is not equal to. All right. What else do you guys want me to talk about?
Probably astronaut.
No.
Whenever it's like no solution and all the numbers.
Okay.
I feel like the no solution one is easy, but I can't ever.
But trying to remember.
Well, not really, because it's just if you see a negative. I mean, I guess, yeah, because I totally worked out the one, number 28, and then I was like, what's wrong with this?
Okay, so if you have an absolute value on one side and a negative on the other, we have to stop and think. You could go ahead and work it out, but it's either going to be one of two things. It's either everything, negative infinity to positive infinity, or it's nothing, no solution. So when I look at this one, I know an absolute value is a positive number. When is a positive number going to be smaller than a negative number?
No solution.
Never, so that's a no solution. This one, I have a positive number bigger than a negative number. When is a positive bigger than a negative?
Always.
Always, so that's the negative infinity to positive infinity.
So, alligator this way is always
Yes.
negative infinity positive.
Stop
Alligator
it.
this way is always